All right, I'm looking at lesson 1, question number 1. And it seems to be, I find in this particular unit, question number 1s in each of the homework are always the trickier ones. So anyway, in this case, explain why it's impossible to express x as a linear combination of u and v when x does not lie on the plane of u and v. So what we need to do is we need to think of a piece of paper. So I'm going to draw my best piece of paper here. So on this piece of paper, which represents a plane, we know that u and v are located on this plane. The question is, why is it impossible to express x as a combination? So a combination basically means that if I had vector x, then I could manipulate and say a little bit of u, so au, bv, would get me from the start of x to the tip of x. But in this case, it says x is not on the plane here. So what that means is that my vector x is off the plane at some angle theta. In order to get from the starting point here to the top of vector x, I need to have some component that takes me off the page. Now vectors u and v, they can move me anywhere on this page from point A to point B, but because they lack an angle that comes off the plane, it is impossible for them to get me on point C. So think of it this way: if you want to get to the top of a house and you don't have the ladder, okay, if you don't have this ladder, you're not going to get to the top of the house. You can run around the house as much as you want with vectors u and v, but there's no way you're going to get to the top of the house without a ladder. So vectors u and v are not providing the ladder to get us off the plane up to the top of point C. So that is why it's impossible. You need to have vectors u and v coming off that plane, and in this case, they are not. So there's your solution or your explanation for question number 1. If you have any questions, please let me know.